Hello, grade 12. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Oabutiwa Sos Ugobela Wemet. And without any further ado, let's get to episode number 4 of today's challenge. Okay, so we have this question 4 taken from a learner who was just trying to attempt this question, and then he reached out to me saying that, Gobela, I've been trying to answer these questions, but then they're just giving me a problem. I do not understand where to start with this question. Can you please assist? And then I just replied and said, I am the maths witch doctor, Nyengu Gobela Wemet. So hand it over to me and then let me show you how it's done. So I hope you enjoy the lesson. And to all of you that are watching, I also hope that you enjoy the lesson and that you finally press the thumbs up button and then also subscribe to the channel if you've been watching this channel and haven't subscribed yet. So without any further ado, let's just get right down to it. So we have a quadratic pattern as a constant second difference of 2, and T5 is equal to T17 is equal to 29. Then 4.1 says, does this pattern have a minimum or maximum value? Justify your answer. Right. So now with this question, I want you to understand, right? So there is some similarity between the quadratic pattern and the parabola function. So this is what I always talk about, to say that in grade 12, the way they will show you the quadratic pattern is they will try to match it with some of the properties from your parabola function. Now, I want you to have a look at these two formulas here. We have Tn is equal to an squared plus bn plus c. And I also want you to have a look at this one, ax squared plus gx plus c. Now you can see that this is in the same format. The only difference is that they use tn and n here, and then here they used y and x. But then your tn is the output and your n is the input, and then here your y is the output and x is the input, right? So this still behaves in the same way. The properties that you'll have for the parabola functions apply on your quadratic pattern. For example, if you want to find out about the minimum and maximum value in a parabola function, we know that all we have to look for is the value of a. We just have to check whether the value of a is a positive or a negative. We know that if our a is greater than 0, meaning if our a is positive, then we end up with a concave up graph. Now, a concave up graph, so this is concave up. It's not a smiling graph, guys. We're just telling you that it's a smiling graph for you to remember, but the actual name is that it is concave. It's a concave up graph, right? So here, this will have a minimum value. So every time we have a concave up graph or a concave up shape, that means our parabola function will tend at the minimum value. Right. So the range will start all the way from the minimum value and then all the way up to positive infinity. But then if our a is less than 0, meaning if our a is negative, then we have a concave down graph. Right. So this is concave down, meaning it would look like this. If it looks like that, that means we have a maximum value. So our graph will start all the way from negative infinity up until the maximum value there. So all we have to find out here is whether our a is positive or negative, because all that we have discovered here applies in this, right? Because it still behaves the same. So just note that. So remember, we are told that the constant second difference here is 2. But then according to our quadratic pattern, we know that the second difference is always equated to what? To 2a, right? So if we are trying to find the n term for the quadratic pattern, we always take the second difference and equate it to 2a so that we find the value of a. So let's do that. We have 2a is equals to 2. Then if we divide both sides by 2, our a is equals to 1. So that means our a is positive, meaning that we must have a concave up graph. If we have a concave up graph, now let's ask ourselves, does this have a minimum or a maximum value? It definitely has what? A minimum value. So you need to say it's minimum. Why? Because your a is greater than 0. Your a is a positive. right? So just like that, you have found your solution and you've also justified. So a greater than 0 means that we will have a concave up graph, and then a concave up graph always has a minimum value. So I hope you understand that. Okay, so let's move to 4.2. It says, determine an expression for the nth term of the pattern. So already we have the value of a. Our a is equals to 1. So that means our Tn will be in this form, right? So this would be, remember, we have an squared plus bn plus c. So if we already have the value of a, this will be in the form of Tn is n squared plus bn plus c. But then we are given here that T5 and T17, they're equal, and they're both equal to 29. So let's start with T5. If we want T5, we just go T5, and then this is 5 squared, and then b. So where there is n, I just substitute 5, because that's the position of the term. But the value we are given, it's 29. And then this is 25, 5 squared, and then here we have 5b, and then plus c. Okay, let's try to make c the subject of the formula. So this will be c, and then if we take this over to this side, 29 minus 25, that's 4, and then the 5b will now be negative 5b. So I hope you follow along with that one. So 4 minus 5b, that's our equation number 1. Then let's get to T17. We have T17, that means where there's n, I'm now going to substitute 17. So 17 squared, then b, this is 17 here, and then c. So T17 is also 29 as well. And then this will give me 289. Punch it in our calculator, then plus 17b, then plus c. If we take all this over to the side, then c being the subject of the formula, we have negative 260, and then minus 17b. So this is our equation number 2. Now at this point, we can see that equation number 1, c is the subject of the formula. Equation number 2, c is the subject of the formula. So at this point, we can now see where we are headed. We can just equate the two equations. So let's say equate equation 1 and equation 2. So let me just do it here. And then if I equate the two, this is 4 minus 5b is equals to negative 260 minus 17b. Now all I can do is just all the ones with the variable of b to one side. So this is negative 5b plus 17b, and all the constants one side, negative 260 minus 4. This will give me positive 12b, and then this will give me negative 264. We need to divide both sides by 12, and then b is equals to negative 22. If we want to find the value of c, we can just choose one formula here. So one equation meant to say, so it can be equation 1 or equation 2, whatever you are comfortable with. But I see that equation 1 is the simplest, so let me just substitute here. So this is 4 minus 5, and then in the place of b, I can now substitute negative 22. Passing all that into your calculator, we have 114, right? So that means our Tn will now be what? N squared minus 22n, and then plus 114. So this is Tn is equals to n squared minus 22n plus 114. So based on that, so we have the value of a, b, and c. So that's how you were supposed to tackle that question. Okay, and that's it for today. So if you've enjoyed the lesson, please press the thumbs up button. And if you've been watching the videos and haven't subscribed yet, please subscribe. And then most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.